Good morning and welcome everyone to today's DIH Talk. My name is Santiago Uribe Diaz. I am a digital transformation advisor at Lux Innovation. For those of you who are new to this platform, there is a discussion window where you can interact and post messages throughout the session. And we also have a questions button where we encourage you to put all the questions that you have during the session. At the end, we will have a Q&A where our speaker will gladly answer to all these questions. Today's topic is leveraging 5G to transform industry, use cases, benefits, and limitations. So this is an interesting topic. Today we will learn together what are practical uses of the 5G technology in the industry and how you can use this technology here in Luxembourg. So now let me talk to you a little bit about the DIH and our services. So the DIH is the Digital Innovation Hub. We are a project 100% financed by the European Union and Luxembourg without invoices or administrative procedures. And the main goal is to digitalize the SMEs in Luxembourg. We do this in different ways. So we have the assessments. The assessments are questionnaires that you can fill online in our website or in your facilities in person with our help. And the idea of these assessments is for you to discover what is your digitalization level in different dimensions in your company. And for you to find out, according to your answers, if it makes sense to invest first in cybersecurity or maybe in an ERP system or in automation. So yeah, very interesting for you to discover that. It's like the main entry to a digitalization project. Then for cybersecurity, we work together with the Luxembourg House of Cybersecurity. They also have an assessment completely oriented to cybersecurity. So you can discover through this questionnaire if the policies of cybersecurity are good or bad in your company. And then you can also do a workshop with the LHC in which they will tell you, depending on your answers, what could be the recommended actions for you to increase your cybersecurity. And also a very interesting initiative they have is the Room 42. So this is a real room in the Luxembourg House of Cybersecurity. And there you can simulate a cyber attack to your company with their help. So you can use the real data from your company and go through this simulation with your staff. And yeah, it's a great way to prepare for a real cyber attack because unfortunately, these attacks are happening more and more. So very interesting opportunity for you to participate on this with the LHC. Then on skills and trainings, we work with the University of Luxembourg. They can analyze what are the training needs of your company and what do your employees like as a training. They can do a match with this information and prepare for you a training roadmap that can tell you which are the recommended trainings that you should follow during the next year with your company. And in technology tests, we work with the list, which is present in today's DIH talk. And they have workshop sessions in which they teach the latest trending technology topics in a very interactive way. So if you attend to these workshops, there is a laptop there for you provided by the list, and everything that the instructor is explaining, you can test yourself during the training. So a very interesting and interactive way to learn. And there is also the Test Before Invest program. So we know that investing on new technologies and digitalization represents a considerable amount of money. So if you have something in mind where you want to invest, you can reach out to the list and participate in this program. And they can see your data and the solution together with you and tell you if it makes sense or not really for you to invest on this technology. And finally, we have awareness on funding. So these are sessions similar to the one of today, but completely oriented on explaining you what are the funding opportunities and helps provided by the Luxembourg government for SMEs. And now, before introducing you to the speaker of the day, I want to ask you for your help. We are currently trying to find out what is the preferred language for these webinars. So if you want to vote, it would help us a lot, and it's very simple. You just need to scan the QR code that you are seeing on the screen and answer just one question. Do you prefer these webinars in English, French, or German? So I will leave this for 5 seconds so you can vote. Thank you. Okay, thank you very much. So today, please help me on welcoming the speaker of the day. We have with us Sebastian Fay. He is head of the Distributed and Intelligent Connectivity Research Group, also known as DISCO, at the list. Hello, Sebastian. Pleasure having you here.
Hello, thank you for the kind introduction. I guess you can hear me. Everything works well. Yes, good. Thank you for the introduction.
Very good. The floor is yours.
Okay, thank you. Well, I have so many slides to present, so just do not hesitate. I guess we have the options there to post some messages, comments, questions. So do not hesitate. I mean, I will try also to have a look at the questions when as soon as they come. So I'm sharing my screen now. I guess this is visible to everyone. Yes. Okay. So indeed, my name is Sebastian Fay. I come from LIST, so the Luxembourg Institute of Science and Technology. I guess you all know about this research and technology organization, but for those who do not know what is LIST, well, it's a research center. We are located in Luxembourg. We have several different sites, and we are doing research, applied research, meaning that if you have, let's say, any issues, if you have any topics, that seem, well, let's say, risky to address on your side, we are basically there to help. We are active in many different domains. So, of course, today will be dedicated to networking, to 5G, but we are also quite active in other sectors. So, I will not detail exactly all the domains of LIST that LIST is covering. But yeah, as it has been said before, especially in the context of Industry 4.0, do not hesitate to contact us. We are very happy to support the development of more innovation at the country level. This is basically our mission. And so coming back to me, so I'm indeed leading a research group which is really focusing on connectivity. We know that connectivity is present really everywhere today. It's quite a big challenge actually, and I will give you some insights here. And so again, I have quite a lot of content to showcase. So just do not hesitate to ask your questions. So I really would like to start with this. What is 5G? This might be familiar for most of you. Maybe for some of you, it's just an icon, that you see on your smartphone. So I will just give some context. I mean, what is 5G, and why do we need 5G today? Why do we need all these generations? And this might be quite abstract for the people. So I will just start with these two plots. I mean, these two plots are quite known in the community. They have been, let's say, estimated by Ericsson and Nokia. So, I mean, I guess you might know Ericsson and Nokia. I mean, they are two of the most popular manufacturers, of networks. So most of the equipment deployed in Europe is actually provided by Ericsson and Nokia. And on their side, they estimate that the data generated by our mobile devices every day is basically increasing quite a lot. So if we compare what happens, for instance, what is supposed to happen between 2020 and 2030, we see a factor of 10. So meaning that tomorrow we will generate even more data through our mobile devices, meaning that we need the technology, to accommodate this increase in data. So of course, there we are talking about the public domain. We are talking about what happens for the general public, for the companies. But this is also quite applicable for industrial sites. We know that with the rise of automation, the rise of all these new industry processes, robotics, and so on, we know that we will need more and more wireless connectivity. And so this translates into this kind of increase. So we need the technologies, to accommodate all these changes. And this is why we are talking about all these generations. So if we have a look, a bit at what happened in the past. So of course, 5G, the fifth generation, means that we already had four generations before. And it's actually quite recent, if we take if we see what happened this last few years. So this all started in the 80s with what we can consider as the first generation, let's say. At that time, it was quite a revolution to talk about mobile networking, to have the possibility to, let's say, make phone calls, while moving. It was a revolution. And then more or less every 10 years, so this is the time it takes, to create a generation, we had, let's say, new functionalities that appeared. So with 2G, we had the let's say, the development of text messages. Then with 3G, we had access to what we called at that time the baby internet. So it was, the start of, let's say, getting access to some form of data, but still limited. And then I guess the real revolution was with 4G in 2010, when we also had access to many applications and then to more data. That was, I guess, several years ago, the first phones, and now I guess you are all used to this kind of phones. So now we are talking massively about 5G. This has been deployed in Luxembourg starting from 2018, and now the territory is quite well covered, actually. And for 5G, this is the first time we are, let's say, not only thinking about the general public, but here the idea is really to create new services also for companies. So this was the case before, but for 5G, I guess the real interest, of having this new set of technologies, this new generation, it's really to enable a new class of applications and services. And this is extremely useful, I guess, for industrial sites and for many different applications and many different sectors in general. We have with 5G we have quite many changes, in the architecture, in the way the network is made. So that's quite a revolution. And we are a research center, so meaning that we are working actively on developing new 5G applications, but we are also looking into the next generation. So this might sound crazy for some for some of you, I'm sure, but we are already working on 6G, so the next generation. And so one important thing to retain is that every generation is an evolution of the previous. So we are not changing everything when we move from one generation to another. It's about adding new functionalities in blocks so that it's easier for the industry to, let's say, to standardize, to come with commercial offers and so on and so forth. So that's why we have these generations, because it's such an effort, let's say, worldwide, that it's better to aggregate by generations, let's say. So voilà, just to give you a bit of context about what is 5G, I guess it's important. But what is even more important for today is to, let's say, try to understand, try to see the interest of this new generation of connectivity with, Industry 4.0. I guess we are all there for that. Sorry. This image is quite well known. So that's the traditional way, we see the let's say the different let's say evolutions of the industry sector. So we are considered today as being in the Industry 4.0 era, meaning that we now have access to many different cyber physical systems. We have access to sensors, IoT, network. So compared to what happened in the past, where it was mainly about pushing for more mechanization, for putting electrical energy, assembly lines, mass production with Industry 2.0, and then a bit of automation and electronics in Industry 3.0. Now we are in the era, let's say, of this full digitalized world and then processes. So of course it's quite a challenge for sorry, for the industry and for the companies in the sector to fully switch, to this full digitalization, mainly because of the history and the time it took already to build some businesses. So another view is this one. Just to see what changed, let's say, at each step. I will not go into all the details, and I know that there is even a debate in the community. Comparing Industry 4.0 and even 5.0. So some people also consider that we are in the Industry 5.0 era, but then let's say there is no consensus yet in the community. The most important is that today connectivity, I believe, is at the heart of everything. So if we have a look at an industrial site, typically, you might have cables everywhere. You might have processes that are faster and faster. So you need to communicate data, and you need to communicate, let's say, information between different machines, between humans and the machines, between, so that the processes are running just well, smoothly. And what was before done with cables, is not necessarily still, let's say, efficient and well, able to develop meaningful applications today. So that's why we are more and more talking about putting wireless into industrial sites, for instance. That's why we are also talking about deploying massively, industrial IoT applications. There is a huge, let's say, amount of new applications and services we can deploy, thanks to all these new trends and technological trends related to robotics, AI, so that we can take real-time decisions. So again, I will come back with more examples after, but just to mention that we are indeed in this era. So that's the switch that, well, I guess is currently happening. I know this might be tricky for some businesses, but this might, in any case, happen in the future, switching from cables to wireless. So I guess until now and still today, there are many different connections that are enabled with cables and Ethernet. But now with 5G, this is, I guess, the first time where we reach the reliability and, let's say, the speed, and the latency of Ethernet cables. We can even go a bit beyond that. So that's the idea why we see worldwide more and more industrial sites deploying and using 5G or wireless connectivity, because it's more flexible, to deploy this kind of technology. You don't need cables everywhere. And then this also means that you can move around the site without any cable. So this can enable quite a few applications. Some people are also talking about Wi-Fi. So of course, when we talk about the wireless networking in general, we can talk about whatever is standardized through 3GPP, so 4G, 5G, 6G, what you have mainly on your mobile device. But then you also have all the Wi-Fi universe, let's say. So Wi-Fi is a bit easier, I would say, to deploy, mainly because you don't need any license to deploy Wi-Fi. You can just buy a router and then deploy it at several points. But then, of course, it performs a bit differently compared to 5G. Here you can see some general KPIs, let's say, to compare the two technologies. But if you need latency, so if you need a very small delay for your application, Wi-Fi, I guess, is good for most of the cases, but then 5G can offer better numbers. If you need mobility or roaming, so the fact is that, well, probably with Wi-Fi, you will need to deploy way more access points. So if you have a big building, for instance, then probably you will need to deploy maybe 10, maybe a few, maybe up to hundreds of Wi-Fi access points. While for Wi-Fi, well, it's more powerful, so you need less antennas, let's say. This means that in terms of mobility, when you are moving in the industrial site, then you will need to switch from way less antennas, let's say, between each other. So yeah, just to offer a small comparison, let's say, of what is possible between Wi-Fi and 5G. So I guess the two can make the job. It really depends then on the applications, on the needs, and that's just to mention that. And again, if you have any specific question here, we can cover. So I guess the three decisive advantages of 5G over Wi-Fi, these are the three there. So sorry. So first, mobility. So what we call the handovers between the antennas. I guess it's easier when you have 5G. The capacity of that can be managed as well is a bit different, and so the number of devices that can be ingested by one single antenna is better in 5G, and then the reliability is also quite better. So the fact that you need specific licenses for 5G, this means that it's more complicated for people outside of the industrial site, for instance, to create interferences, and so this means this is more reliable and probably slightly more secure. So now, well, I just would like to introduce some potential use cases, also introduce some examples we have at least, because we have worked now for several years on this topic. So I will introduce some projects there. Sorry, not the good morning to talk. Unfortunately, I'm slightly sick. So the first use case I can introduce, that these are just ideas and things we see regularly on the market. One example, for instance, that you could deploy with 5G, which is a bit more tricky if you do not have access to any wireless connectivity, is, for instance, to get access to remote expertise. So we could imagine here using a tablet, using a phone, using even a headset, for virtual reality or augmented reality. And the idea then is to benefit from a remote expertise. So let's imagine you have a machine, you have something which is broken. Then you can maybe call someone located at several kilometers, located in another country. And then since we are talking about very specific machinery and issues, then the remote expert could take over and then see exactly what happens in the machine, and then help the worker there on the industrial side to let's say to solve the issue. So that's a typical use case, that might need wireless connectivity, because in that case you do not want cables everywhere. So there you also need something quite fast, and again, which comes with low latency, because you will be moving, you will be sending high resolution video. So there you need quite a good capacity for your network. That's typically one example. Another example is to interconnect robots and what we call cobots, so where you have an interaction with humans. And there are many different examples that are currently being tested in Europe and worldwide. The idea is to basically facilitate the connection of this new equipment when they are deployed in an industrial facility. Because you can imagine that if we need to cable all this, then it's quickly a nightmare. I guess these robots can also move, so meaning that it's better if the connectivity is flexible behind. And there, there are several tests, and that have been done, trying to compare other technologies versus 5G. And here you can see some numbers. The improvement, in the delay, in the reactivity, is quite better, simply because the technology is better. So there, this can enable quite a few other possibilities. Then we have AGVs, so automated guided vehicles. This is quite also a common use case which might require connectivity. So here the idea is to have again these small vehicles, communicating between each other, or maybe with the infrastructure, again in wirelessly, to transmit information in real time and see to detect objects, for instance, or to ease the supply chain there, or anything. So the idea of connecting all that could be, for instance, to go for predictive maintenance. So collecting in real time a vast information from the sensors of these AGVs, or also sensing the environment, so that you can predict or anticipate what could happen potentially before this happens. So all these use cases need mobile connectivity. These are examples, of course, and it's very tricky, to give. We could cite probably more than dozens of examples, but just to give you the interest, to show you the interest of having a technology like 5G deployed in the context of industry. Now, if I step back and look a bit at what the research is offering, this is also quite important. So what I showcased before, these are common use cases. You can find them in Europe. We know that there are already trial sites and even places that are already implementing that. But then if we have a look at the future, I was talking about 6G, but this is also partly applicable to 5G, let's say. Then you can see quite a lot of many different use cases. This is a classification that has been done here with, through a research project called L-DIH. So this is a flagship project at the European Commission level, dealing with, let's say, the definition, the standardization of, future CG systems. And I will not go through everything there, but you can basically see that some use cases can refer to vehicle communication, for instance. We can also have a bit of, let's say, environmental monitoring. I see sustainable food production, local coverage for temporary usage. So that's also quite important, in case you have a failure in your network, in case you have anything. Now we can use these new, let's say, technologies for offering temporary coverage. We can, of course, it can act as an enabler for AI. We know that AI is more and more distributed today. You can execute AI close to you on your device in the cloud, and so of course you need connectivity to interlink all that. The digital twin. Obviously, this is quite a topic on digital twins for manufacturing. So basically, creating a sandbox, to test and optimize processes before applying them into the reality. Here, you need to collect data and act on a physical system in a very, very, very fast way. And so these are all cases that might need what I just showcased. Now I will just introduce, the text is not that much important. I guess I will be able to share the slides right after the seminar. But it's just to showcase some examples of, activities, projects we have done here, at least. And again, if you are interested by any of this activity, or if you have any idea in mind, I highly encourage you to contact us, because we like working on this. One example is the teleoperation of drones and robots. So here you can see some small robots. We have in the lab a robot dog as well, equipped with a LiDAR sensor, so that the robot can understand and see its environment. And you can also see a drone, which is, which was at that time teleoperated remotely. So if I remember well, the demo related to the drone, the idea was to use a 5G link to teleoperate, the drone, and then the idea was to use the drone for, scanning different QR codes that you can probably see, which were on boxes. So that's a typical use case, for warehouse management. So if you have to store items in a big building, for instance, then one way is to use drones. We know that some big, let's say, logistics companies, for instance, are using this already. And here the idea is really to automate and to teleoperate, so that this can ease the process. So that's a typical case. We are so active. It's slightly less connected to industry might be connected to industry 4.0, obviously, but mission critical communication, it's also something. So until now, to manage some communications that needed urgency, we had and we still have dedicated networks for that, like Tetra. Some networks that are highly proprietary, but still in use, for instance, by the emergency services, or might be also in use in specific contexts. But now the idea is that we can use 5G and the public network, a part of the public network actually, to run mission critical communication systems. So that's typically a project which is called 5G Crico. We are running it with Post at the moment. And one of the use cases we have in mind is for railway. Obviously, railway needs, we are talking about highly mobile systems, high mobile systems. So there we need, we are studying, let's say, the integration of this mission critical communication. So we want to guarantee that at any point in time, any point in space, we have access to communication in case there is a failure or an issue. And we believe that 5G is the right technology for that. So implementing all of this on top of the conventional 5G systems. So might be very reliable for industrial sites. Another project, and I guess this is the last one of the list, which is quite important for us at the moment. It's running. It's partnership where you can see big names like Orange and G-Core. It's a project called Smart Spire. So this is funded by the European Commission through the CEF Digital Framework. This is basically what we call an infrastructure project. So also to show you that research is not only about papers, making theoretical concepts, it's also really about deploying new things. And so here it's quite amazing. I mean, this idea was, I guess, described on papers maybe 10 or 15 years ago, but now we have the possibility to really work on it. So what we are doing here is really to combine communication and computing together. So usually when you have access to AI, when you need AI, the computing resources, they are located on very distant servers, maybe located even in other countries. Here, the idea is to deploy this kind of tower. So, of course, the design is just an example. Now we have, there are some other possibilities. And inside this tower, you have, 5G, and you also have computing capacity. So this is what we call edge computing, meaning that when you send the data to the tower, then you can almost immediately have the data processed inside the tower. So this means that you almost never leave the tower, digitally. So of course, this is extremely good. This is an extremely good use case for industry, because then, in terms of data privacy, GDPR compliance, and so on, well, that's quite good, I guess. But this can also enable very low latency. So we can process data in a very, very efficient way. So we could totally imagine this kind of tower, well, again, maybe with another design, deployed in the middle of a factory, for instance, to manage all the connectivity that might be done here. So we are currently doing that in Belval. We have a few deployments, let's say, that are planned in theory, and I got the confirmation yesterday. So this is really ongoing. We will get one tower deployed at least mid of June. So if you are interested by this kind of project, we can organize visits. We can organize some demos, so that also maybe you can integrate the story. The project will be running until 2028, and we are looking for people that are interested in that. We are looking for use cases. So if you have any ideas, we are super open to discuss that. I see my colleague Prune Gauthier is also connected, so we are working together on this project, and very happy to discuss it. I guess I have a small video here just to showcase, again, that's just an example of design. At the end, the design will not look at all, it will be slightly different. Let's say it will be slightly more squared, but just to show you the kind of object we are talking about. Again, we'll pass the video. I see the time is also flying. Voila, so that was for the use cases. And now, we are reaching almost the end of the presentation. So I will just talk a bit about private and public 5G. So that's also a novelty we have with, let's say, 5G. Not really a novelty, because some options were there before, but we have discussed a lot about it in the community, and I know it's a typical case for industry. 5G is today deployed in the public domain, right? It's you need licenses to have frequency bands. You have mobile network operators that are, managing this, not managing, but that are exploiting these frequency bands. It's very regulated, and this is, again, mainly in the public sector. But with 5G, you have, at least a new possibility is to deploy private networks. Again, the possibility was there before, but now it's maybe easier with 5G, let's say. And this is something we have experimented. So here, what you can see is a part of our lab, and 3 very motivated colleagues working on some of the robots and instruments we have here in the lab. So the idea, again, is to have a full end-to-end 5G network, which is private and dedicated to your needs. So that's the extreme case. Then we can have, of course, a hybrid setup. So we can have semi-private 5G networks, let's say, to say it like this. We can also have some, we can also rely on the public 5G network, and then make use of what we call network slicing. So there are many different options, but that's the idea, to get access to a part or to the full network for the need of an industrial site or a facility. And of course, this is quite important and interesting for this kind of cases. So on our side in Belval, we have access to a test frequency band. So meaning that we do have a private 5G network. The interest for us, of course, is to discuss with people that are interested, and then invite us to test this kind of network, because of course we are not a commercial entity, so we can test many different options before deploying them into the reality, and then potentially making the contacts with the network operators. And of course, for research, it's also quite important because these networks are open, so we can implement our own algorithms on top and then go even beyond the standards. So we are regularly playing with that. It's quite tricky, honestly, to now present all the options that come when we discuss about private networks, but it's really to be studied on a case by case basis. And here we have some options, for instance, that are available. There are commercial entities all around Europe that are selling this kind of facility, to run private 5G networks. So here you have two of them. For instance, you have an example of the frequency bands that are supported. So we know the options, and again, it really depends on the needs you might have. And this is working quite well. It's quite light as well compared to the big infrastructures that a network operator usually need. But so yeah, voila. And we have different tools also available in case you want to test, for instance, what could be the difference between installing a private 5G network, Wi-Fi, using the public 5G network. We have all these tools, to try to test again things before going further and investing into these technologies. So this is ranging from simulation tools, as you can see here, but also more physical tools that can help you going further. So that's a bit of promotion as well for Belval, and it's quite important for us. We are located in the Belval campus in Luxembourg, and we are really, let's say, considering it as a test bed for research, a test bed for connectivity research, where we try to push for new applications. We are very active, for instance, in the mobility sector. We are obviously active in the industry sector. And so here we really see this campus as a way to move forward, when it comes to 5G and future 6G networking. I will soon be short of time, but I will try to accelerate, so that you get the full view. I might skip some slides. But that's the main challenges we are facing today. I think so far 5G has been there, a few years, let's say for a few years, but we are still a bit struggling, to let's say push for new applications and services, mainly because we need, the technology needs to be adopted, and this is also quite aligned with the way this sector is moving and implemented. So. For instance, this is a very popular citation from the former CEO of Ericsson and the current CEO of Verizon. So, for instance, 4G was started to be designed before the smartphone was around. So this means that this takes so much time, to deploy a new generation, that usually we start thinking about this generation before the applications are actually there implemented, before the need is actually here. So now this is changing a bit with 5G and 6G, but just to let you know that implementing use cases, there is a need there, and this is also a bit our role to push for that. Here you can see some cool videos and photos of what we are actually doing in Belval when it comes to mobility. So all this, of course, needs to be connected. At the top, you see a simulation of Belval, which is actually a kind of digital twin of, some, let's say, processes that happen in our lab. So we are very much used to do it. Again, it's I think we are quite lucky also to be in Luxembourg, and we have quite a a lot of facilities when it comes to testing new technologies. And again, I think if you have a look at the European level, we have quite a good deployment of 5G. The current challenge related to Industry 4.0 is definitely the deployment of private networks and the development of business cases. So there we are ready to co-invest and to co-design also things with you. The opportunity is definitely to test different applications before investing in them. Here you can see some logos of including some of the initiatives I already cited. As I told you before, we have also some opportunities in related to 6G. So yeah, I mean, again, we'll not go into the details here, but just to mention that if you have any interest in the field, if you have any application in mind that might need connectivity from far or not, then we are really there to support this, and we will be pleased to do so. So that's a bit. These are a bit the key takeaways. You know why 5G can potentially change the connectivity game. Let's say. So again, the fact that we can have wireless enabled at industrial scale, so we definitely need this kind of technology unless you want access points a bit everywhere. Speed, latency, coverage, so the pure performances of 5G, this is definitely something important, which is way better than what we had before with 4G. Mobility and stability, I guess we will need that in the future with robots, vehicles, humans. And then if we want to move to new AI applications, to new smart interfaces, let's say, for Industry 4.0, 5.0, and beyond, then we can use that as a foundation for the next, for enabling these next generation services. We still have some challenges, and that's why I'm representing a research institute. So the regulation, the standardization, some of the cost, of course, to cover, to deploy 5G. I mean, these are still not a barrier, but this is obviously things that need to be addressed. Use cases need validation. Yeah, we see more and more use cases and trial sites deployed in Europe, but not necessarily at large scale. So that's also why Luxembourg can be potentially used as a national testbed for that. And hybrid is the future. So even if I'm here today to speak about 5G, I mean, our role is also to be a bit agnostic, from the technologies that might exist. And so potentially in the future, the best solution to manage connectivity in industry will be to mix a bit, the different technologies and assets that might exist. That's also a bit the vision of 6G. So this is not just a number. The idea at some point is to try to aggregate, to federate all these technologies together. So yeah, I guess that's it from my side. I mean, I just had some other slides, but might be too short to present them. Just to mention that, we are also dealing with whatever is beyond 5G. So again, with 6G, I will not go there because these are clearly things I already mentioned. About what is 5G, what is 6G, the fact that 6G can act as an enabler for future AI applications. I will just mention that as well because this is something which is not known probably, but just to mention that we are quite active in Luxembourg in general. I'm not talking necessarily only for myself, but in this ecosystem. Europe is really trying to push a lot for the development of next generation connectivity. And Luxembourg is very well represented there. This is whatever we are doing here, and I'm not only talking for LIST, but also for the university and the local research ecosystem. We are quite well represented, let's say, at the European level, and we really try to push, for this new, let's say, research and to get more let's say, meaningful applications and services targeting next generation connectivity. So, for instance, we are currently coordinating this project, which is called 6G Twin, which is supposed to define some of the baselines, for the next generation, connectivity systems. This is one of the few initiatives that have been funded by the European Commission, and we have a seat there. So that's quite a positive message. And I will definitely not go there. Thank you. That's my phone number. This is my email. So again, do not hesitate to reach me. Very happy also to make the link with other colleagues. And with that, I guess I'm out of time. Thank you.
Thank you so much, Sebastian, for this interesting talk about 5G and all the projects. So
Thank you.
let me put back this.
I see many questions. Well, actually not.
Many questions. But I thought about one question. In terms
Good.
of, yeah. Oh, well, actually, we do have a question now. Fateme Kabe Madhavani. So good morning, Fatima. Thank you for your question. The question is, good morning all. I am Fateme with a PhD in AI in 5G wireless networks. I am so curious about the new techniques and solutions in 5G, 6G wireless communications. I enjoyed Sebastian's presentation. Thank you for organizing the session. Thank you so much for your nice message. Hope you enjoyed. And
Well, thank you. I can give a quick answer. I love this question because it's a way for me to come back to a slide I managed so quickly.
Perfect.
Yeah, what is 6G? So again, I mean, just to, I guess we could have further discussions together, Fatime, but the idea here is just to, I guess, try to give a few keywords, about 6G. Because again, behind this number, I guess people are it's not clear for necessarily for people what does it mean. So as I shared at the beginning, I guess we are now facing quite a massive industrialization of the digitalization of the society. The same goes for industrial sites, and AI is also a bit everywhere. So we are talking about that massively more and more about AI-driven applications, services, and so on. The issue is that, this implies quite a lot of data to be exchanged. And I guess one of the main challenge we have will be to implement AI for automating a bit the way the networks are operated today. Today, I mean, we have many things are still managed in a static way. So, for instance, the energy of networks, it's something that can clearly be optimized. If there is no traffic, for instance, during the night, I guess an antenna or a network system should adapt. So today we already have solutions in place, but it's not necessarily everywhere. So that's typically, the kind of challenges we will be addressing with 6G, to have networks that are way more adaptable to the constraints, I guess. I could speak 10 hours, but on other topics, but just to show this slide, I guess there you have many keywords. But happy to discuss outside of this meeting, of this webinar.
Thank you so much, Sebastian. So, with this, thank you everyone for your participation. Do not hesitate to scan the QR that you see on the screen. That way you can see all the events coming from the DIH. And again, thank you, Sebastian, for this interesting insight. Very complete, very useful.
Thank you for the invitation. Thank you again to my colleague Prune for the link made here. And have a nice day.
Nice day, everyone. Bye.
Goodbye.